So we actually spent we spent last session talking about how to set up your your own Python environment. So no worries. No, today I'll go through that stuff quickly. And today I would kind of like to give you guys a chance to do some coding as well. So I've put in some exercise blocks. So it'll be good if you manage to run all the stuff on your side. Talk through all the stuff we're gonna go through. And then there'll be checkpoints where you can kind of have a go yourself. I'll give you a few minutes, to work it out. You can ask questions if you need to. You can put things in the chat. Yeah. So okay, so let's going. So last week we kind of talked about, generally speaking, what we're doing here. So we're looking at, kind of the basics of what makes programming. Like, what is a program? What does it do? We talked a little bit about what are the components of any kind of program. You have things that get processed, output, and some kind of storage. These are kind of the basic building blocks. Now I talked a little bit about Python, and the Python is one of the more popular languages out there. I think it's quite powerful, but it's also very readable. It's very easy. I think it's easier than many other languages to get started with. Because when you read Python code, usually it's kind of largely easy to understand. I mean, for someone who's not programmed before. So that's kind of a quick rundown of what we're doing and why we're using Python. We did run through variables very quickly. So these are basically, storing data in labels that we can use later on in the code. And you can see here that I went through, some example variables and how they're typed. So, what kind of data are they? Are they numbers? Are they strings? Are they true or false? If you want to kind of revise or go back, or maybe if you're new to the show, there's a link to my GitHub in the event. But what you can basically do is you can look through last year's stuff if you wish. You can look at last week's session in here, and the README tells you how to get going on your local machine. So how you can download what you need, Python environment, and then a source code interface. So we use Git here, but you can download Tortoise Git, and then you can get like a Git interface in your file explorer. So it's much easier to work around these kind of code repositories if you have something, a tool that you can locally use to navigate all that stuff. So I won't go through detail of that now. But like I said, don't panic. When we pause for our first exercise, I will stop and I'll give you some space. If you want to ask stuff, have questions, you have problems with your setup, just tell me then. I'll read the chat as well. So anything you need there. Okay. So anyway, today is control flow. A control flow is really about, you think of it as how do you want to workflow your code, or how might your code branch, or how might your code repeat? Because when you write code, we're kind of moving things around. We're probably reading data, and we might be doing something. But you might want to at some point choose what to do. So that's what conditional is. Like, there is a condition. Is it this or is it that? And your code will do different things. So that's a very common thing in code. Because typically in software, once you have data, you need to make decisions around what to do. So conditionals are, you can think of them as branches in code. If this, else this, we're going to also look at loops. So loops is, as you expect, a code that goes round, round, round until something is done or something happens, and then we leave the loop. So the concept is quite simple. You guys can understand. Yeah.
Once you
what's
have,
going on.
once you have,
So let's just dive into the conditionals. So there are really three keywords we use for conditionals. And they're kind of natural in the sense that they are, if, else, and elif, which is short for else if. And it's a little bit easier maybe to understand if you look at the examples.
once you have,
Because the um, if basically just says, um, I want to test the condition. So here we have a simple one. We have an age variable assigned to the number 20.
once you
And we're
have,
saying if age is greater or equal to 18, then you print you're an adult.
once you
So
have,
this is simple, right? There's a variable. We want to check the variable to see what it has, and
once
we'll
you have,
base behavior on that. Obviously, if you change it to 17, nothing happens because you're not an adult because this is not triggered. So if else is kind of like an extension to that. So if else gives you a way to say to specify what happens if the first condition isn't met. So earlier on we had just a single if, but obviously if the if doesn't match, if this is false, if it's not true, nothing happens in this case. But we have an else condition to basically catch any condition any situations where the conditional isn't met. So again, a really easy one is age. So if you're less than 18, you're a minor. Whereas obviously if you're greater, then you're an adult. So pretty simple stuff. Um, one last thing I'm just going to throw in here is the elif. Now elif is basically short for else if. So this gives you the ability um, to create a number of conditionals. Um, so if the first condition doesn't match, it goes on to second. So what basically happens is that if you have an if, elif, and an else, you can have lots of elifs, and each elif is an else if, which means that if the condition above doesn't trigger, then you test the next one. So you can add different conditions. So here, less than 13, less than 18, you could say I don't know, if you're less than 40, you are less than 40. If you're less than otherwise, if you're less than 60, you say you are less than 60. So you can see how the control flow basically goes through each one line by line. And so either you hit or you get into the else. And the else is the catch-all block, right? It's when everything else doesn't match, you end up in the else. So as you can see, um, 18 is not so this condition is less than 18. Obviously, if you put less than equal to, then you are a teen. But if you put 19, you see how it skips the first and second conditions because they are false. But then age less than 40 is true. So then it enters this block and then it stops. So I hope that's kind of straightforward. Hope it makes sense. Um, what I'm going to do now is set an example for you, exercise for you guys. So for those of you who have Jupyter or whatever Python environment home, I was going to give you a few minutes. I don't know, 3-4 minutes maybe. Um, have a try. See if you can write some code here. Um, see if you can do this. I'll be around if you want to ask questions. Just fire away, or type in the chat. Um, we'll see how you get along. And of course, if you have any questions about setting up, fire away as well. Remember, if you have any questions, let me know. Okay, I guess that's about 4 minutes. So firstly, any questions, or does anyone want to volunteer an answer? You can paste it into the chat if you want, or I don't know, share screen, whatever. Let me know. If not, I'll show you the my answer, my solution. Nice. Okay, cool. All right, yeah. So let's see. So let's just have a think about it. So we have a number. Yeah, let's put it as 1 for now. So we want really kind of want you kind of like I said. So there are 3 cases. There's positive, negative, 0. So the easiest way. So there are a few ways of doing it. Well, I'll show you what we recommend. So obviously the first condition is let's say negative. So negative means it's less than 0. So that we can print and if greater than 0, you can say so we have 0 as an outcome. So we're going to say that greater than 0 is positive. Now, we can obviously say elif number equals 0, blah blah blah. But these are things that's just for else, because we know that for the three outcomes, there's going to be either negative, positive, or 0. So if it's not negative, positive, then it's going to be 0. So it's good to check what's going on. So 0, then this one. So hopefully that was straightforward for everyone. Let's move on. So uh, I might end up combining some of these exercises to avoid lots of awkward silences. But let's go through. So I'll go through the loops. I'll go through the loops and then we'll do the exercises at the end, I guess. Okay. So with the loop, the idea is that we want to be repeating some code many times. Now the temptation usually is what is sometimes when you're first starting out, when you're thinking about some code running a few times, the temptation is just copy and paste. But copy and pasting isn't great. The main reason is that if you make a mistake, you gotta fix it in many places. If you want to change it, you gotta change it in many places. So, like, this is a very simple example, but actually, in general, in software engineering, you really want to avoid duplication at all costs. And as you learn more advanced coding, you'll kind of learn more about the architecture of code and how you structure code and that kind of stuff. But anyway, for now, we'll talk about loops. And I guess normally when you think about loops, there are two kind of loops. There's a for loop, and then there is the for loop, and then there is the while loop. And they both iterate, but they do it in slightly different ways. Now, when you use the for loop, you have to use it on a sequence. Now, a sequence basically can be a list, or it can be a range. Let's stick with list for now. List is kind of more easy to understand. So here we have a list called fruits with 3 fruits. And what the for loop does is it goes through every element of an iterable, every element of a sequence. So here it's kind of straightforward, right? So what it does is for each element here, it's going to enter this loop here. And I'll keep doing that until it gets to the end of the list. Pretty straightforward stuff, right? We'll skip this to a bit later on. But so why don't we do 2 and 3? We'll do 2 and 3 together later on. The while loop is a little bit different. So the while loop, instead of giving it a sequence of stuff to list over, the while loop will keep going until something is met, a condition is met. So this is useful if you don't know in advance how long your data is. So in this case here, we are going to keep counting basically until we are no longer in the case where count is smaller or equal to 5, which basically means that when you reach 6, right? Because when you reach 6, count will no longer be smaller or equal to 5. And once this is false, the loop breaks and it stops running. So fairly good example, right? I mean, the condition doesn't have to be. It can be anything you want, right? So it can also be going backwards, and that's what we're going to be doing in the an exercise here. We're going to be going counting backwards. Okay, so we'll take a checkpoint here. I'll give you guys 3-4 minutes again. So there's 2 and 3 here. So exercise 2, you want to write a program which prints numbers from 1 to 10 using a for loop. Now I've given you a tip. If you don't want to, if you want, so the easiest way to do it is to use a range. So a range object basically is a kind of a Python construct that gives you a sequence given some conditions, and the conditions are basically x and y. So if you do like range from 1 to 11, what you then find is that it gives you a list which is from 1 to 10. Right. So the range takes in the first number, and then it gives you the end condition, I guess, but the end number is not included. So as you can see here, 1 to 10, 1 to 11, sorry. It stops before it hits 11, so it gives you 10. So you can use this kind of stuff basically to put numbers. So I realized I've just given you the answer, so that wasn't great. But hey, maybe we can do exercise 3. I'll try not to give away the answer this time. Exercise 3. Okay, so exercise 3 is we want 10 to 1 using a while loop. So you want something like this, going backwards. So yeah, I'll give you 3 minutes, 4 minutes. Any questions? Just let me know. Okay, that's enough time, I guess. Let me know if you want more time. Um, Let me know if anyone wants to give the answer, or if not, I'll take you guys through it. This is probably a good time for me to give you guys the Odyssey code, um, because we're about half an hour in. Okay, so yeah, for those of you who are waiting for the Odyssey code,
Win code.
code, we code the okay. So the code is it's all in small letters. I'll put it in the chat as well, but it's TTH block coding, one word. TTH block coding, one word. Just pop it into the chat for you guys, or maybe there you go. Perfect. Thank you, Chinese routine. So there you go. The code is in the chat. Enjoy. And while you guys are putting those codes into the Odyssey, I'm just gonna type up the answer for you guys. So hopefully you got that answer, or you can kind of see what we're doing. It's kind of, as you can see, it's very simple. Very similar to the example we had. We're just taking away one each time rather than adding. Cool. So I hope that was straightforward for everyone. Again, shout if you have any questions or want me to go over anything again. Okay, so when we talk about nesting, really we're just talking about kind of loops within loops. So layers. So this is a little bit. I mean, it might not come to you obviously what I'm talking about. So so what I would say is that when you have a nested loop, you have the outer loop first of all, the loop which is so this kind of gives you, I guess, the first layer. So this is going to be going from iterations based on the sequence. Now in each iteration, so in each time this code runs through one of these iterations, sorry, this code runs as well. So one kind of way to visualize it is, I mean, this code kind of prints out the different variables. So you can see that in the first iteration, like range I is 1. So you can see here that I is gonna vary between 1 and 3, because the range gives you the upper limit. So you can imagine that in each loop, each iteration of the outer loop, I is going to be 1, 2, and 3. Now, whenever I is a value, remember that the inner loop is going to be running as well. So what you basically get is that in each outer iteration, the inner one is looping between 1 and 3 as well. So you're seeing here that while I is 1, so while we're in the first iteration of this loop, we are going through this loop 1, 2, 3, right? And then once this loop is run entirely, then we go back to the second iteration of the outer loop. So you can see that when I is 2, we're also again going from 1, 2 to 3. And so you can kind of see where the nesting is happening. Each inner loop is running completely for each iteration of the outer loop. So you might wonder why on earth we do this. You can kind of see here from the exercise that it's if you're working with like matrices, a matrix of numbers, it's very common to have a nested loop because we basically have two dimensions. We have the rows and the columns. So thinking of a nested loop as dimensions in a structure is kind of also a nice way of thinking about it. The depending on how you work it, typically I is like a row, isn't it? In math, and J is like a column. So I mean, I hope that makes sense. You know, just shout if you want any clarifications. I do have an exercise here, but maybe I'll roll it. Maybe I'll roll it together with exercise 5. Yeah, I'll roll it together with exercise 5. I'll come back to this. But in we're going to go through the exercise. Basically, we want a grid like this. Yeah, and so yeah, I'll go through that later. Okay, so we've kind of seen conditionals and loops. Now, sometimes you might want to end the loop early. One good example is, you know, if you're going to write an algorithm that finds an item in a list, you want to find an item in the list. You can kind of see how we want a loop that goes through every item in the list. But if you find the item, you want to stop. You don't need to keep on going. So that's the idea we want to think about when we have break and continue. Break and continue, these words in a loop signify that we're going to stop the loop before the natural end of the loop. There are kind of two ways of doing it. The break, basically, if you see a break, then the loop stops entirely. So if you ever get a break, the whole loop stops, and you go on. The continue is a little bit different. Continue is used to skip only the current iteration, but we don't stop the loop. We keep going with the loop, so the loop carries on. So you can see here that if we comment out the break, oops, sorry. Nope. Let's try again. So the natural loop is 1 to 5 because we have a range here. So if we didn't have any breaks, we would get 1 to 5. But the break says if the break says stop the loop completely. So the condition says here we're saying that if we happen to hit 3, we're going to stop. With the continue, on the other hand, if you remember, the continue skips the current iteration, but it keeps going after that. So it doesn't end the loop completely. So again, the natural loop is 1 to 5. If we say continue, you're going to see that it's going to skip, but it won't stop. So you see that it has skipped 3 because we asked to continue, but it keeps going. So again, so these are useful for sort of finding algorithms. So very often you want to often you have a loop because you want to do something over a collection. You want to look for something in a list, or you want to go through elements in a structure to do stuff. Sometimes you want to stop because you've reached the target, and then you use break. Sometimes maybe you want to skip the current iteration, maybe because you found a data element that is corrupt, or you found something that is not relevant to your search. Just skip it. Just go to the next iteration. That's when you use continue. Okay, so just let's go to exercise 4. So let's go back to exercise 4. As usual, fire any questions, fire away, either here or on the chat. But what we want to do is we write some code that's going to print out a grid, a 3x3 grid of numbers. It doesn't have to be 1, 2, 3. It can be anything, but we want a grid of numbers, 3x3. Now I've given you a tip here, which is that normally if you print something, it adds a new line after each call. So we don't want that. We want, we want to print 3 numbers in a line. So to do that, you can use the print, but you override the n parameter with a space. What this means is that after the print has run, it doesn't use the default ending, which is a new line. It uses space. Of course, when you get to the end of the line, you want a new line. So then you want to use standard print. But okay, yeah. So I'll give you guys a few minutes, let's say 4 minutes. Have a go. Oh, I think that's probably enough time. Let me know if you want more time or anything. Any questions? Anything not clear? Let me know. Nested loops are a little bit. I mean, it's not. It's not too difficult, but sometimes if you need to run it a few times to get your head around what it means to be nested. I'm just gonna start typing out the answers as well. You can kind of imagine that it's kind of similar to this one, to the example I gave above. Because oh, yeah. If you have a question, let me know. No worries. Okay. Anyway, so yeah. So we kind of you can kind of imagine that we have a very similar idea here. So we want to be iterating for 3 rows, 3 columns. So this is kind of how we do that. Now we don't want to print out I and J. We want to print out some kind of number. What we can do actually is let's just say why don't we print out J? Because J is kind of in this case going to be 1, 2, and 3. So that could be kind of a nice thing to do. So if we just do this, it's going to print it out, but in kind of let's look at Wingman's answer. Yep. Yeah. Okay. So Wingman. So this is okay. So the thing is, so let's give it a try. So you have 3. You kind of have 3 nested loops. 1, 2, 4, and you're printing out a string with I, J, K. Okay, so I guess when you run it, you'll see that it's doing something like it's kind of close to what we want. You can see that it's doing like a block of code. So what we can actually, so it turns out that we actually only need 2 loops. The reason is that we have basically, so if you think of each nested loop as a dimension, we have 2 dimensions, rows and columns. So what actually ends up happening is that we only need 2 loops. Now, the trick though is that we want here I've used 1, 2, 3, so that kind of makes it a little bit more confusing because the natural reaction is to say, okay, you need three loops. But we can actually you can just do it with 2. Now, if I just print out 2, what it's going to do is going to basically print out. So let's say we do, yeah, let's say we print out J. Now with J, so you can see that it's going to basically it's going to print out 3 times in each. It's going to do 3 rows or 3 columns. And J is going to be 1, 2, 3. So if we run it like this, it's not going to look right. It's going to look a bit weird because it's going to be like in a column. So the trick here is that we wanted to do 1, 2, 3 in one row, 1, 2, 3 in the next row, 1, 2, 3 in the next row. And the reason it does it like this is because the print statement always has a new line by default. So we don't want to do that. We want to actually override the end parameter. So, oh, sorry, I didn't tell you this, but if you do Shift Tab in Jupyter, it gives you a help. Shift and Tab gives you a help pop out here. Yep, exactly. Cool. Exactly. Yeah. So yeah, with the end thing, you have, if you basically, when you say end, it basically means don't do the default end, which is a new line. Do a space. So this will print space after 1, 2, and 3, which is good. Now we do want a new line. We want a new line though at the end of each row, which means we need to come back. We need to come back to the outer loop. You see, the code is aligned with the outer loop, but we want to do a print here. So then what happens is that it prints 1, 2, 3, J, and with the ending with space. So 1 space, 2 space, 3 space. And then at the end of the row, which is the end of the first iteration of the outer loop, you want to print an empty string, which, as we know, also gives it a new line. So that's how you get the block of numbers, and it can be any number you want, but 1, 2, 3 is just kind of convenient. Cool. So yeah, nice. You're close. That's quite good. I did put another exercise here, but maybe what we'll do is we'll leave as homework. So, when you guys, so yeah, for those of you who are downloading stuff, no worries. Once you've got it working, I changed it a little bit because I realized it was the same as the example. So I'm gonna push this to the GitHub repo. So you're gonna have to print numbers 1 to 10, but skipping 3 and 5. So this is gonna be using the what we learned around break and continue. Yeah, so that's homework, guys. When you have time, give it a go. As always, ping me if you have questions, anything. You can't get it working, you can't get the Anaconda working, you can't get Git working. Just let me know. And I'll help you out. Cool. So next week is the 3rd. So today we went through control flow. Next week is the 3rd session, which is functions, and more advanced data structures. Obviously we looked at the dictionary, which is a structure. But we're gonna do some more stuff around structures. I think when we go through functions and structures, that's kind of I guess that's what I would say is the meat, because with functions, with structures, with control flow, with variables, you've got enough kind of building blocks to write a lot of code. Obviously there's stuff you need to do around that as well, but hopefully that after number 3, you'll be good. Cool. Okay. So I think that's it for today. Any questions?
Nice, cool show. I don't have any questions necessarily, but yeah, that was fun.
Cool. Thank you. Yeah. Thanks. Glad it was interesting. Any feedback on what you want to see differently as well? If you want to change stuff, do you feel like it's too many exercises, or if you want more exercises, or if you want something, if you want a more difficult task, let me know. Yeah.
101, right? Yeah, keep it simple here.
Yeah, exactly. Yeah. Cool. All right, nice. Yeah. So thank you very much, everyone, for tuning in. Yeah. So I guess we'll call it a day. Have a go at the exercises, exercise 5. And yeah, anything, just let me know.
Cool, thanks, man.
No worries. Thank you for coming. Yeah.
Thank you, TDH.
Thanks, Esper.